Welcome to The Explainer. So today, we're tackling something literally every single business deals with, but honestly, very few have actually mastered. I'm talking about what happens when things break, right? Whether you're wrangling massive software deployments or drowning in thousands of customer support tickets, troubleshooting has pretty much always been this frantic, reactive, stressful mess. But that's changing, and it's changing fast. We're going to explore how AI is completely flipping the script across both customer support and software engineering, turning that manual scramble into a hyper-proactive automated machine. Let's get right into it.
So how exactly do you find a needle in a digital haystack? Because really, that is the fundamental question here. In modern digital systems, whether we're talking about endless log files of code execution or an inbox just flooded with 10,000 angry customer emails, the issue isn't a lack of data. Not at all. The real problem is cognitive overload, data overload. There's just way too much noise for any human being to process quickly enough when an urgent issue arises.
All right, here's a quick look at our roadmap for today. First, the troubleshooting crisis. 2, AI and customer support. 3, decoding emotion and intent. 4, solving the software haystack. 5, phase-aware log analysis. And finally, number 6, the future of troubleshooting. Let's jump in.
Okay, starting off with part 1, the troubleshooting crisis.
Let's compare the old way with where we're actually heading. The old way, it was all about sequential queues, first come, first served. You process tickets or read log errors in the exact order they hit the system. But here's the harsh reality. Customer patience is basically zero right now. And marketplace slag SLAs, those service level agreements are unbelievably strict. If you miss an SLA on Amazon or Walmart, boom, you lose your buy box eligibility. The old sequential queue simply cannot handle that pressure. We absolutely need this new way, AI prioritization based on actual real-time urgency.
And this little scenario hits the nail on the head. Picture this. 2 messages land in your support inbox at the exact same millisecond. The first is a totally polite customer just saying, "Hey, tracking says delayed, no big deal." The second, a furiously typing customer shouting, "3 weeks? I'm filing a chargeback and leaving a 1-star review." I mean, we've all been there, right? Now, in a sequential queue, they get treated exactly the same. So by the time your human agent finally clicks on the furious customer's ticket, the damage is done. The review is up. The queue worked exactly as designed, but the outcome was a total disaster.
Which brings us to part 2, AI in customer support.
This is exactly where AI steps in, acting like a highly calibrated smart magnet to instantly pull the most critical issues right to the top of the pile. Notice this 4-stage breakdown of how AI sentiment analysis actually works here. It starts with text ingestion, stripping away all that useless HTML and signature fluff. Then linguistic analysis kicks in, where NLP engines really dig into word choices and sentence structure. Step 3 is classification and scoring, which assigns a numeric intensity to the message. But step 4 is the absolute game changer, the action trigger. Look, if your AI just labels the ticket as angry but doesn't actually escalate it or bump up its SLA deadline, you didn't buy a prioritization tool, you just bought a fancy reporting dashboard. The action trigger is literally everything.
Moving right along to part 3, decoding emotion and intent.
You might be wondering, just how smart is this linguistic analysis? Well, modern AI comprehension is way more advanced than just hunting for negative keywords like bad or broken. To really grasp this, we need to clear up 3 terms that software vendors constantly mix up: sentiment, intent, and emotion. Okay, so sentiment is just overall polarity. Are they happy, neutral, or unhappy? Intent is what they actually want to achieve. Do they need a refund, or are they just reporting a glitch? And emotion goes much deeper, into specific feelings. It tells you the difference between someone who's just mildly disappointed and someone who is violently angry. By layering all 3 of these metrics together, the AI creates this hyper-accurate priority score. It knows exactly how the customer feels and exactly what they want to do about it. So who's actually doing this well? Here's a quick cheat sheet on the help desk landscape. You've got tools like eDesk, which is phenomenal for e-commerce because it literally glues deep order context and shipping data right next to that sentiment score. Then there's Zendesk, giving you massive enterprise-level flexibility. Freshdesk is awesome if you're a budget-conscious mid-market team. Gorgias is laser-focused on Shopify web stores. And Zoho Desk is just a natural fit if you're already living inside the Zoho CRM ecosystem. The right choice completely depends on your specific business context.
All right, let's pivot to part 4, solving the software haystack.
We're leaving the front-of-house customer support behind and heading straight into the back of house. We're talking software engineering and CI/CD environments. Here, the haystack is made of millions and millions of lines of machine logs, and if you write code, you absolutely know this pain. You get a failing test, you tweak the code to fix a minor data seeding issue, you rerun it, and boom, you get a brand new assertion error. So incredibly frustrating. This iterative debugging cycle creates a massive headache. If an automated tool just compares your new failing logs against your original successful ones, it gets completely overwhelmed by what we call semantic noise. It sees your data seeding fixes plus the new assertion error, making it almost impossible to pinpoint the true root cause of the failure.
But AI solves this with a brilliant trick called dynamic baseline selection. Instead of blindly comparing the current error to the last passing run, the LPR, the AI actually realizes you're stuck in an iterative loop, so it intelligently shifts its comparison baseline over to the previous failing run, the PFR. Actually, think of it like this. It completely filters out the semantic noise of your previous fixes, so it only focuses on the log differences introduced since your last attempted code change. It's a massive time saver.
Let's dive deeper in Part 5, Phase-Aware Log Analysis.
This is where large language models really start to flex their muscles on massive text dumps. Traditional log comparison just takes two giant files and slaps them side by side. Not very helpful. But this AI pipeline? It's phase-aware. It literally segments the integration test into distinct execution phases: setup, data seeding, execution, assertion, and teardown. Because it understands these phases, the LLM compares the corresponding segments directly to each other. So if the test failed during an assertion, the LLM knows to focus entirely on the unique semantic differences found exclusively in the assertion phase logs, completely ignoring all the harmless background noise everywhere else.
And the way it pulls this off is through a sequential pipeline of autonomous AI agents. Think of it kind of like a relay race. First, the context retriever finds the correct baseline run. Then it passes the baton to the artifact collector, which fetches the raw logs. After that, the phase-aware semantic analyzer jumps in to find those critical differences we just talked about. Next, the root cause synthesizer turns all that highly technical gibberish into a clear, natural language diagnosis. Finally, it hands off to the ultimate agent, the solution proposer. Now, this solution proposer uses a really cool technique called retrieval augmented generation, or RAG for short. It takes that synthesized root cause and cross-references it against a massive internal index of your company's own engineering docs and previously solved issues. So it doesn't just report the error to you, it actually proposes a highly actionable code fix or points you to the exact internal documentation you need to solve it. It literally completes the entire troubleshooting pipeline autonomously.
Which brings us to our final section, Part 6, the future of troubleshooting.
Whether we're talking about soothing angry customers or keeping those CI/CD pipelines perfectly green, we are witnessing a massive shift. Beyond just comparing past and present, unsupervised machine learning platforms, like the ones developed by Science Logic, are taking things to a whole new level. They structure the logs, they score anomalies based on how rare or severe they are. Then they correlate those anomalies across totally different log streams and match them up with metric spikes. And the best part? They use GPT models to instantly summarize the issue and spit out a root cause report. It learns the patterns automatically. No massive, manually labeled datasets required. It proactively uncovers your blind spots before they turn into a full-blown system outage.
And look, the real-world business impact here is just undeniable. According to research by Metrigy, companies deploying these AI troubleshooting tools are seeing 20% to 32% improvements basically across the board. We're talking actual, measurable revenue growth, hard cost reductions, massive spikes in customer satisfaction scores, and way more efficient employees. When you strip out all that digital noise and give your teams exactly what they need to fix the problem, everybody wins.
Which leaves us with this final thought. We've seen exactly how AI acts as this deeply intelligent filter, taking mountains of chaotic data and turning them into prioritized, actionable insights. When AI can dynamically debug our messy, iterative code changes and instantly calm our most furious customers by prioritizing their needs, it fundamentally changes how we spend our time at work. So, what impossible problem will you ask it to solve next? Thanks for joining me on this explainer, and keep learning.